Okay, so there's something about dot products and A's and B's and cosines of something or other. Okay, first, here's an A and a B. Where's a cosine? Wait, what do I take cosines of?
Angles.
Angles, right? Okay, so where's the angle in this picture?
Between
the two vectors.
Between
the two pictures here. Okay, so my claim, I suppose, is that there's some kind of a useful thing about dot products and angles. Okay, and so we draw this picture, and then we say what? Okay, let's make a triangle. All right, so what's that vector there?
A vector plus B vector.
Kinda.
A vector
Squared.
plus C vector? Or times
Okay.
A plus
A
A
over
vector?
sine.
Let me see. So this is a vector, right?
Yeah.
And when I add it to A, I get
Oh, B minus A?
B. So it's the B minus A vector.
Oh.
Oh yeah.
Okay, see that? And what do I really mean by B minus A?
B plus negative A.
I mean, it's B plus negative A, right? Okay, so I got this, and now what do I know about law
Sines.
of cosines? Yeah, so do you guys remember the law of cosines? What does that thing say?
Yeah, something like that.
B squared plus C squared plus 2
Hang on, there's like a minus 2 and it equals. No?
Yeah, it's something like
So it's like the Pythagorean theorem, right? Except it compensates for the fact that it's not a right angle. So this bit here has a cosine of theta in it. And that thing zeroes out because cosine of pi over 2 is...
One.
Cosine of pi over 2?
Zero.
0, I hope. So that it zeroes out when it's a right triangle. You guys see that? So, what are the pieces that go in here? You're saying A and B, right? Like A, B, and C, maybe? Like they were the sides of a triangle. But what are A, B, and B minus A here?
lengths.
They should be lengths, right? That's what I would label them with if this was an honest triangle. But this is a triangle made out of vectors. So what are the lengths that go with these?
Magnitude A.
Mags. Yeah, so this vector here is magnitude A long. This vector here is magnitude B long. This vector here is magnitude B minus A long, right? Okay, now how do those pieces fit in here?
Magnitude of A squared
B minus A
plus magnitude of B squared.
Oops, I already had a square.
A
So, magnitude of A, right?
vector.
Then the other side that's similar to A, right, is the magnitude of B. And then the side that's playing the role of the hypotenuse in my picture is the B vector minus A vector. So this guy is the magnitude of B minus A. Okay. And what goes in here?
assuming an AB.
Yeah, that's an AB. So magnitude of A, magnitude of B. Didn't have enough space. Okay. Now what?
Theta's the angle between A and B.
Theta's the angle between A and B. Good. How in the heck is this crap related to dot products, though? It's like I was doing dot products a minute ago, and now I'm all jammed up with triangles, right? So where's the dot product in this picture?
Would A dot B be the magnitude of B minus A?
Close. How about these guys? Start with these guys. What's magnitude of A squared? We just learned a way to calculate this.
It's dot product of A
It's
with itself.
Yeah, it's A dot A. Okay, so I got A dot A plus B dot B, right?
Minus 2A dot B.
Oh, that one's worse. I'm just gonna leave that one the way it is. I'd like to say that's A dot B, right? But I don't have a rule saying that. So I'm just gonna leave that thing alone for a second. And then on this other side here, I've got very nice. That's B minus A dotted with itself. Oops, B minus A dotted with itself.
Isn't there supposed to be a cosine on the two?
Oh, dang it. Keep running out of space. A little bored. Not quite big. And there is supposed to be a cosine of theta here. That's the point. Okay, so. What?
You okay?
A dry erase marker all over me?
No.
Okay.
We should have mud all over you.
Oh, that's true. Okay, now what? What does your little heart ache to do to that right hand side?
Multiply it out. Simplify.
Yeah, you want to FOIL that right hand side out, don't you?
My heart doesn't want to.
What?
I know, it's
We
not
haven't
hard.
trained you well at all, huh? Alright, so let me write this. I've got A dot A plus B dot B minus this jazz about 2 magnitude of A, magnitude of B, cosine theta, right? Okay, and on the other side, if you multiplied that out, treating the dot product just like it was multiplication, what would you get?
B dot B minus 2A, well 2 times the quantity of A vector dot B vector, and then A dot A.
Perfect. I maybe should worry about the fact that this should have been an A dot B and a B dot A, right? And I stuck them together.
Mm-hmm.
Is that a problem?
We can go flip flop.
Yeah, the little dot product formula seems symmetrical, right? And in fact is, right? The dot product's commuted. Okay, now what do you see?
So A dot B equals the magnitude of A times the magnitude of B times cosine. If everything cancels out.
This is a number, right?
Yeah.
So I can just subtract it from both sides. Those will cancel. What else?
B.
B dot B will cancel. Cancel. And then we'll...
Two
Add
twos
those
cancel.
twos.
Okay, we'll divide both sides by -2, right? And so you'll get A dotted with B is what? What are you left with?
Magnitude of
Magnitude
A,
of A.
magnitude of B.
Okay. Cool. You want the punchline? So this is a little theorem, right, that we just proved. Okay, but what's the punchline?
We'll never use this ever again.
No, this you'll actually, this you will use all the damn time. But it's not the theorem, it's the punchline that you're going to use all the time. So what's the punchline?
Something equals 1.
Something equals
0.
0. So you might wonder, right? What would it mean for A dot B to be 0?
Angle between them is
Angle
0.
0. Anything.
Angle between them has to be
Oh,
Pi
yeah,
over
pi
2.
pi over 2.
0.
So the dot product of 0 is the same information as they're perpendicular. You guys see that? Cool. That's the little corollary that's really the punchline to this. You guys all good with that? Complaints, questions, things? Okay, I just freaking lied to you all and none of you caught it, so catch it now. How did I just lie to you?
The dot product can't equal a vector. Or the dot.
No. No, most of this is okay. But what did we do? We said, okay, when the dot product is 0, right? That means that cosine of theta is 0. You guys see that? That's not really always true, right?
No.
No.
Because what if
A vector or B vector could
Yeah,
be
because either of the magnitudes could be 0. What's the only vector with 0 magnitude?
zero vector.
The 0 vector. So I also need to add this little caveat to this thing, which is
as long as a vector and b vector does not equal the 0 vector?
we could add that one, or we could add an even easier but weirder one.
Zero vector is perpendicular to everything.
Yeah, so we could get away with saying, right, either this is true when A or B isn't 0, right, when neither A nor B is 0, or I'll just say, what the heck, the 0 vector is perpendicular to everything. That's fine. And then I can take this, dot product of 0, as my definition of perpendicular. Cool. So that's what we're going to use for perpendicular. We're just going to dot product them, see if it's 0. If it is, great, they're perpendicular. Cool.
That's what we did in linear.
Yeah, it's what you do in all multidimensional analysis.